So solubility rules. In your blue periodic table, in the center, either you can get yours out or you can use one that's there. If you don't have one, there's a couple more up here. When it talks about solubility, that middle part in here on solubility, everybody needs to have one. If you don't have one, then get up and get one or get yours out. Okay? Either way is fine. So we're focusing on the solubility rules. This top section up here talks about solubility. All these ions are soluble in water. That's what this heading says. Except these down here. There's exceptions to those rules. Same thing with the bottom part. These are all insoluble in water. They do not like to dissolve in water, except these here. So there's some exceptions to the rule. So when they're not soluble in water, either they won't dissolve or they will precipitate out. So I have this beaker here. I'm going to move this out of the way. And these two beakers of a clear solution, right? And if I pour, I'm going to pour some of that in here. Don't need very much. And when I pour this other clear solution in there, you can see that a precipitate formed. Okay, that means whatever this substance is does not dissolve in water. I can sit here and I can mix it up and stir it up, and eventually you can see it's just not going to dissolve. Okay, that's just the way that it is. So all we're doing is we're trying to teach you how to use these guidelines to figure out which ones dissolve and which ones don't. That's the whole purpose. So I'm going to go through and work these equations for you so it makes it a little bit easier. We're not going to do all of them. Let's look at number 2 first. Okay, we have copper nitrate. If we were to look at our guidelines, you would see that they dissolve in water. It says AQ. I know it's not very easy to see. And sodium carbonate is also aqueous. That's what aqueous means. It dissolves in water. All of our reactants on this side are going to dissolve in water. I mean, just like these two here, okay? There's chemicals dissolved in there. They're soluble. That's just a dark spot at the bottom of the beaker. It's not anything. So all those dissolved in water. Now, this is a double replacement reaction, so they're going to get new dance partners. The NO3 is now going to dance with the Na, and this copper is going to dance with the CO3. So we did this a while back. Are we all following along and writing stuff down? So let's look at them. I'll tell you what the charges are on them. I'm not going to ask you to look all those up. Copper is a +2. Nitrate is a -1. Sodium is a +1. And carbonate is a -2. So you might need to know those later on when we make our little drawing. And we also need to know them when we combine them into the new compounds, like we used to do the little bowl of soup, right? So what are we going to make? Well, Na is going to dance with NO3. And we have a +1 and a -1 that equals 0, so I just need one of each of those. And copper is going to dance with carbonate. We have a +2 and a -2, so I only need one of each of those. Those are our new dance partners. We've done this before, this part. So the question is now, will this dissolve in water? Will the sodium nitrate dissolve? And will the copper carbonate dissolve? So we want to focus on the second half, the negative ion or the anion. So let's find NO3 in our periodic table. And is NO3 soluble or insoluble? It's It's soluble, which means it will dance. It will dissolve in water always. There's never a time that it won't dissolve in water. So anything that has NO3 at the end of it is always, always, always going to dissolve in water. If it dissolves, we write AQ and we put them in parentheses because it's aqueous. It dissolves in water. Then we look for copper carbonate. We look for the second half again, the carbonate ion. It's down here in the second part where it says insoluble, which means it does not dissolve in water. Unless it's one of these exceptions, and we'll come back to those exceptions, but copper is not one of the exceptions. So that one will not dissolve. It will precipitate out. So we're going to write a little S for solid behind it. Okay. So the goal again is being able to read this chart and figure out what's going on. That's the ultimate goal. So let's take this equation now. We'll show you what we're going to do with these little beakers down here. We're going to rewrite the equation. So I had copper nitrate, which was aqueous, and sodium carbonate, which is also aqueous. All I'm doing is writing down what I have written up above, and that's going to form our sodium nitrate, which we said is also aqueous, also dissolves, and we had copper carbonate, which we said does not dissolve. Right? All we did is rewrite that equation. So what would this look like if it was dissolved in water? These ions all split apart. So I have the copper 2 ion, and I have 2 of my NO3 ions. When they dissolve in water, they split apart. They're all swimming around, sitting in a little inner tube, a little floaty device. They're just floating in the water separately. So we'll just put a couple of these different ones in here. It doesn't matter how many I have right now. I'm just kind of showing them spread out. Questions about that? If they dissolve, they dissociate, which means they split apart from each other. They're floating around in the water separate from each other. That's why you can't see anything. Same thing here. This is aqueous. So again, I have them split apart in water. As long as they dissolve in water, they dissociate. They're floating around independently of each other. In both cases, they've split up. I'll let you finish writing those down. Questions on that? Well, what is it going to look like if I dump both of these together into this? What's going to happen? Well, we already wrote down what's going to happen. We just want to try to draw an image. If this is aqueous, is it staying together or splitting apart? Aqueous is splitting apart, just like we did before. So I have a couple of these floating around. Doesn't matter where you put them. As long as it's aqueous, they split apart. They dissociate. What about my copper carbonate? Does it split apart or stay together? It stays together. That's why we have a little S here. That does not dissolve in water. So we'll draw a little pile of stuff down here, and we will label it copper carbonate because it's a solid. So all we're trying to do is draw what is going on. Okay, if it's aqueous, we split them apart. If it's a solid, you keep it together. Questions on that? Don't be afraid to ask. I know there's at least a question every period that should be asked, but nobody's doing it. Okay, has everybody got that picture drawn? Okay. So let's go back up and just finish these for you. We're not gonna do all of them. We're gonna do 6, 9, and 11. We'll do that part together, and then you'll go and draw the diagrams on your own. So again, we said that all our reactants are always going to be aqueous. We always have an AQ by then. And when we split them apart, Ag is a +1, NO3 is a -1. I know it's kind of hard to see, sorry about that. Na is a +1, and OH is a -1. I'll just go ahead and tell you what the charge is on them so you don't have to spend time looking those up. So, what are our dance partners going to be? Na and NO3 have switched partners. Now they're going to dance together. Ag and OH are going to split apart and dance together. It's a double replacement. So we're going to rearrange them. We're going to show them dancing with their right partners now. Na and NO3. Na is a +1, NO3 is a -1. I only need one of each of those. Ag is a +1 and OH is a -1, so that's convenient also. I only need one of each of those. So now we need to look. Are they soluble or are they insoluble? All nitrates, always, 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 are soluble. There's never an exception to that. Okay? So that's going to be AQ. We're looking at the second half, the OH here. We find OH, and which section it's in. The insoluble means it does not like to dissolve unless it's with one of these, and that is not one of the exceptions. So this is going to be a solid. That's what you need to be able to do. You need to be able to use that chart on the test. Okay? So if I were just to give you on the test, if I said AgOH, is it soluble or insoluble? You should be able to look at this chart and tell me which one it is. Okay? That's the goal, and that's the goal for the lab tomorrow. Questions? I don't know if I believe you or not, but if you're not going to ask them, I can't help you. Okay, number 9. We said again, our reactants are always aqueous. In this case, they are. They could try to trick you on a test, but we're not. That's not our purpose. We're going to look at their new dance partners. Na is going to dance with NO3 again. K is going to dance with OH. We'll write down, I'll give you the charges on those. Na is a +1. OH is a -1. K is a +1. NO3 is a -1. I'm mainly doing that so that when you draw your diagrams, you don't have to try to look up what the charges are. You can just use that as it's written. So let's form our new dance partners. Na is dancing with NO3. It's a +1 and a -1. We've seen that one before. And K is dancing with OH. So the question is one of them, are they both soluble or is one of them insoluble? And in these questions, you'll never get two of them that are S's, okay? I wouldn't do that reaction because if I want to form one of them, I don't want it mixed with another solid because then I have to figure out a way to separate that out. There wouldn't be any reason for that to happen. So NaNO3, we've said before, it's a nitrate. It always dissolves. So that one's going to be AQ. KOH, I find my hydroxides right here. They're generally insoluble. Most of the time they will be an S. However, K is an alkali metal. Do you remember which column on your periodic table is the alkali metals? Good, the first one. Right. So one of the other things that can help you a little bit, any of these, no matter what they're attached to, will always dissolve in water. Always, always, always. So anytime you have Li, Na, K, you're always going to write an AQ behind it. So that happens to be one of those. So that's also going to be aqueous. So that's something that you would see that normally would write no reaction because you don't see anything happening. I can mix two liquids together and nothing happens. Okay. And then the last one, again, they're both aqueous. They both dissolve in water. My dance partners, again, is sodium and nitrate. We have calcium and carbonate. So I'll show you the charges on them once more. Na is a +1, carbonate to -2. Calcium is a +2. Nitrate is a -1. You see that? Yeah, you can see it. And now let's rewrite our dance partners. Na dances with NO3 again. Do we have to look that one up again? Or is it soluble? It's soluble. It was soluble in all the other ones up above, so it's going to be soluble again. And then our other dance partner is going to be calcium and carbonate. One's a +2, the other one's a -2. So that's just a 1-to-1 ratio. So we look at our solubility table. We find carbonates. They're generally insoluble. They do not like to dissolve. Okay. So, and it's not one of the exceptions, so we'll write a little S behind that. So on here, this was problem number 2 that we did that drawing of, right? So you're going to write the reaction and do the drawing for number 4. Oops, sorry. Number 6. What happened? 1, 2, 3, 4. I'm missing one. Oh, I skipped number 4. Oh, we'll be okay. I'm going to let you guys get by. Number 6, number 9, and number 11. Okay? Yeah, you can leave the last one blank. So all you're going to do is sit there and draw the diagram. We've already done the problem, so all you have to do is recopy the reaction down and then draw the diagram on what is happening. Okay?